All right, with this video, we're going to use Geometry Sketchpad to help us look at the equations of circles. All right, so I've got a point here. A, the coordinates is at, as you can see, -4, 2. And I'm going to put another point. I'm going to move up 1, 2, 3, and over 1, 2, 3, 4. Okay, and I'm going to plot that point right there. And then, of course, I'm going to label its coordinates. And then, of course, the coordinates there are at 5, 0. Then I'm going to draw the segment from A to C, which is effectively going to be my radius, which you should suspect is 5 because, okay, I moved up 3 and over 4, so there's my right triangle right there. So my length of that, of course, is going to be 5. Nope, sorry, wrong thing. The length of that, measure the length of that, is going to be 5, right? Okay, now I'm going to, my radius then of my circle is set at 5. My center of my circle is set at -4, 2, and I'm going to draw my circle now. And with the center at A, and the 1 point on the circle at C. Okay? And I'm going to ask Sketchpad, what is the name of that circle? The equation of that circle. So I'll right click on that. I'll find the equation, and here's the equation of that circle. Now, it should be of no surprise, okay? The circle whose equation is x plus 4, the quantity squared, y minus 2, the quantity squared, equals 5 squared. Which really should look familiar to you. It really is the distance formula. It's a distance formula applied between A and C, okay? And whereas the distance is 5 units. And basically, it is the equation of a circle where the center can be identified right here as the x-coordinate, and this actually we'll learn is actually read x minus the x-coordinate, which we'll call h, and y minus the y-coordinate, which we'll call k, is equal to the radius squared. So there is your form for the equation of the circle. Now, okay, if I move this, then we're going to reflect the changes in it. Okay, if I increase my radius by pulling on C and making a larger or smaller circle, okay, then you can see what changes is the length of the radius, but the center stays fixed at -4, 2. Okay, so you can obviously see how that's controlling. Now, I could actually move the center too. So if I move the center here to -3, 2, what's impacted is right here, is the location of the center. So you can always tell the equation from the equation of the circle where the center and the radius will be. Okay, if I move my center down here onto the y-axis, onto the x-axis, mainly at the -3, 0, then that's reflected in my equation here as well. Okay, notice that of course the y-coordinate of the center is at 0, so this collapses. Instead of it wouldn't actually, what it reads is the quantity of y minus 0 square, but there's no need for that. Okay, if it were shifted to the x-axis here, okay, and accordingly, so now here we see it is okay at the center is at 0, 2. The center is at 0, 2. Of course, if I were to center it right there at the origin, okay, and pull that up, maybe to as much as, hopefully it doesn't seem to want to lock in exactly on 6, but there it is. Okay, so x squared plus y squared equals 36 is the circle whose center is at 0, 0, the origin, and whose radius is is 6. Okay, so there you have it. Okay, the equation of the circle contains, okay, the ingredients of the circle, mainly the center and the radius. So the normal form for the equation of the circle is going to be the quantity x minus the h, which is the well, let's put it this way. Given a circle of center h comma k, generally speaking, and of radius r, the equation is going to be the quantity of x minus h, closed quantity squared, plus y minus k, closed quantity squared, equals the radius squared. Okay, and so that's kind of like a demonstration. Again, if I move it down to here, notice that there's no y coordinate in the center of the circle. Well, there is. It's 0. So, in other words, seeing this equation, even without the graphics here, just with the equation alone, you should be able to state that the center is at 5, 0, and the radius is, okay, 7.81. All right. And or if I said to you, okay, well, here is a circle. Let's say we could do this. Okay, let's put it right here. Okay, so we can obviously see. Stretch it out a little bit. So we can obviously see here is a circle of radius 7, whose center is at 7, 6. So there's a circle of radius 7 whose center is at 7, 6. So either way, given the information of the circle, that is the center and the radius, you can easily write the equation, or vice versa. Given the equation of the circle, we should easily be able to identify the center and the radius. Okay, and we'll have a follow-up video to show some actual calculations.